A helicopter hovers over an active volcano. Below, a river of glowing lava flows at over 1000 degrees Celsius. The crew opens the door. A single egg is held over the edge. 3, 2, 1. Drop. The egg begins falling. For a few seconds, its fate is already sealed. Or is it? Most people think they know exactly what happens next. It just burns. But that's not actually the whole story. Does it explode? Does it float? Does it instantly disappear? Or does something far stranger happen first? To answer that, we are going to follow this egg from the moment it leaves the helicopter to its final second inside one of the Earth's hottest places. Let's begin. Before the egg even touches the lava, let's look at what it's facing. Fresh lava is typically between 700 and 1200 degrees Celsius. That's hot enough to melt aluminium and make many rocks glow bright orange. Our egg doesn't stand much of a chance. Its shell is only about 0.3 millimeters thick. Inside, mostly water, along with proteins and fats. And surprisingly, that water is about to become the star of this experiment. The egg reaches the lava. You might expect it to sink immediately. But lava isn't just hot liquid, it's a molten rock, and it's roughly 3 times denser than water. So our egg, which is mostly water, floats on the surface instead. But here's where things get interesting. When the egg first meets the lava's 1000 degrees Celsius surface, moisture on the outside of the shell rapidly turns into steam. That steam can briefly create a thin insulating layer between the egg and the lava. This is known as the Leidenfrost effect. For a fleeting moment, the steam slows the transfer of heat, but it doesn't last. The intense heat quickly overwhelms that tiny layer. Within a second or two, extreme thermal shock creates tiny cracks in the shell. The reaction has begun. Here's where things get interesting. Inside the egg is liquid water. When it's heated this quickly, it flashes into steam. And steam occupies roughly 1700 times the volume of the same amount of liquid water. Imagine inflating a balloon thousands of times larger inside a fragile egg shell. The pressure rises incredibly fast. If that steam can't escape, the shell ruptures violently. Not because lava explodes, but because the water trapped inside the egg does. Once the shell breaks, the egg white and yolk spill onto the lava. Normally, heat slowly cooks an egg, but lava is not a frying pan. It's hundreds of degrees hotter. The proteins rapidly burn, carbonize, and decompose. Instead of breakfast, you get smoke, steam, charred organic material, and ash. The egg doesn't have time to cook. It's destroyed almost instantly. Here's something surprising. Lava doesn't destroy things only because it's hot. It destroys them because it transfers enormous amounts of heat extremely quickly. Anything that contains water, food, plants, wood, or living tissue can produce steam almost instantly when exposed to that much energy. That's why volcanic environments are so incredibly destructive. So what actually happens when an egg falls into lava? For a brief moment, it survives. Then physics takes over. The shell cracks. The water instantly flashes into steam. Pressure overwhelms the shell, and within seconds, the egg is gone. A simple egg against molten rock from deep inside the earth. There was never really a contest. If you enjoy uncovering the science behind questions most people never think to ask, consider subscribing to The Fast Engineer.